This chapter is looking at faults and faulting. When the rock breaks, whether it's because we're removing the load-bearing toe, like in the little cartoon here, or whether it's something completely natural going on due to plate tectonics. Now, first we want to cover some terminology to make sure that we understand what the different things are involved in a fault and what the different types of faults are. A fault is any surface or zone in the earth where measurable slip develops. So the rock is broken and there's been movement along that break. So different than the joints that we were looking at last chapter. You can see here in this example the chunk of rock on the right has slid down compared to the chunk of rock on the left. The little fence makes it really clear that this happened recently. A fault zone is an area with a bunch of faults making a net movement. So there are several faults and a definable band where all the movement is happening between, this right-hand block and the left-hand block, and in between there's smaller parts of rock that are moving as well, and we have, or may have, cataclastic flow and cataclastic deformation along those fault planes. A fault splay is something that you'll see from overhead, and it's where you have a primary fault and then you have small faults that break off of it. Almost looks like braided streams, except in this case, instead of being river channels, they're faults in the rock. The fact that it looks so much like the braided stream, also called an anastomosing river, is why this is called an anastomosing structure. Now, within a given fault, we have fault blocks. They're the large bodies of rock that are either the stationary portion or the moving portion. And a wall is the rock directly adjacent to the fault surface. So we can have the wall below the fault and the wall above the fault, and those are the blocks of rock right there. A hanging wall is always the block above the fault plane. A footwall is always the rock below the fault plane. So regardless of which way the motion is, the chunk underneath that plane is the footwall. Easy way to remember it is you could walk on the footwall with your feet. The hanging wall, the actual fault surface of that hanging wall, if you took that chunk of rock and separated it from the footwall, would be above you. You could walk under it, you could grab onto it and hang from it. That's the hanging wall block. Slip is the displacement. It's the motion. If one fault block slides relative to another, whether there's up-down slip, side-to-side slip, both, the total motion is called net slip. And we can describe this with a vector, with a magnitude, direction, giving us the total sense of slip. The sense of slip is that relative displacement. Now, relative is an important part of that term, though, because in this image, for example, it looks like obviously the hanging wall has moved down. However, it is equally possible that the footwall was thrust up. and the hanging wall stayed stationary. It's the total sense of relative displacement that is marked when we give a vector for the net slip. Now we can break it down into two parts, like any vector can be broken down. We can have the dip slip component and the strike slip component. Strike slip is side to side. Dip slip is up and down. So no matter what angle your net slip vector is at, you can break it into some amount of side to side and some amount of up down. You can see right here where my mouse is circling, there's an angle between this net slip vector and horizontal. That angle is called rake, or the rake angle, usually signified with the symbol theta. And later, quite a few labs down the road, we'll talk about rake. And so hopefully you guys will remember. If not, I will remind you. The rake angle is the angle between horizontal and this net slip vector. So dip slip is the up-down movement, strike slip is the side-to-side movement, and when we have a combination of the two, we can call it oblique slip. A normal fault is when the hanging wall moves downward, like that image that I showed at the very beginning. You think of it as sliding down a slide, sliding downhill. Moving down is a natural thing since gravity pulls us towards the ground. In geology, this is a more common kind of fault, and it has been termed normal. A reverse fault is the opposite of the normal fault, the reverse of it. This is when the hanging wall moves up relative to the footwall. So the normal fault, the hanging wall moves down. Reverse fault, hanging wall moves up. A thrust fault is a very special type of reverse fault. So it's still a reverse fault, but it has a very, very low angle of inclination. So instead of being, 40 degrees or 45 degrees, it's down around 10 or 15 degrees. So you can see here on the left is a normal fault. The hanging wall has moved down, and on the right we have a reverse fault where the hanging wall is pushed upward. It rides up the ramp. So how are we going to name the displacement so that we know what's going on? Okay, we have a normal fault and we have a reverse fault, but what about something like the San Andreas fault? Everybody's heard of the San Andreas fault. It's moving side to side. How do we describe that? Well, in a fault like that, if you stand on one side of it and look across the fault, the things on the other side will have either moved to the left or to the right. It doesn't matter which side of the fault you stand on, it's going to be the same. So if you look across and you see that, hey, everything over there moved to the right, we call it a right lateral, or we call it a dextral fault. So dextral means the same thing as right lateral. On the other hand, if we look across our fault and everything seems to have moved to the left, we can call it a left lateral fault or a sinistral fault. Now, it is important to also know which way you're facing. not because it's going to change whether it's a right lateral or a left lateral fault, but rather because this helps give an orientation. So if you're facing north and you say there's a right lateral fault as I face north, we know the fault direction is an east-west fault. So in these strike-slip settings, we have a right lateral fault shown on the left here, where regardless of which side of the fault you're standing on, if you look across, everything moves to the right. In image D, we have a left lateral fault, or sinistral fault. Whichever block you stand on, if you look across the fault, everything seems to have moved to the left. And then, as I mentioned earlier, we can have oblique slip faults. This is when both the side-to-side and up-down motion are happening. And so we get 4 cases. We can have a right lateral reverse, right lateral normal, left lateral reverse, left lateral normal. Now, it might seem like, okay, we've covered all possible cases. We've got side to side by itself, up down by itself, side to side with up down. But nature likes to throw us a curveball and add in some rotation. We can have a scissor fault. So we have up down, side to side, and twisting all at once. Isn't geology awesome? Anytime we think we've got it all figured out and nice and tidy, nature's like,